multiply, divide, joke. Yes. Number 3. So if I look at number 3, I'm going to take 9 times 7, and 9 times 7 gives us how much, Emily? 63. I'm going to have times 10, and we just use our exponent rules, and we're multiplying, so that means I'm going to take 3 plus the negative 1. So I now have 63, if I'm looking at that, times 10, and I should have had times 10 to the second. But this number is not written in scientific notation. It's 63, and in scientific notation, it should be 6.3. And so if I had to move it 2 places, now I actually have to move it times 10, and it should be to the third power. So 6.3 times 10 to the third is what I am looking for. Okay? Other questions as you were looking at your homework there. So you wouldn't have seen 10 to the second, but you would have seen 10 to the third. Shaylee, on this page. Number 11. So in number 11, we were looking at showing this multiplication, which I had on the notes last week. So you had to take 3 times 2.7. What did you get when you took 3 times 2.7?
I didn't do that.
Okay, so grab a calculator. You want calculators for this stuff. Come prepared, have your stuff out. So you're going to multiply that. And then it should be times 10. In this case, 8 plus 5 gives us 13, right? This should be 6 something or maybe 7, right? What'd you get? 8.1, thank you. So I get 8.1 times 10 to the 13. 8.1 times 10 to the 13. You just really had to finish the problem that we did in class, okay? Again, these were on the daily planner with these notes. On the other sheet, then you had 1 to 10, or 1 and 7 to 10. And then you had this division worksheet. So this joke sheet, the 2 joke sheets are what we're handing in. This is the one we got Friday. Yes?
What were the 2 riddles?
Oh, so let's look at those. On the first one, anyone want to read the first one? What did Dr. Watson say about Sherlock? There's no police like Holmes, like no place like Holmes, no police, you know. Anyone watch Sherlock Holmes or any of the Sherlock, any of those shows that are on? Okay. So on this one, did you hear about, someone want to read us their answer? Kyle.
The 2 guys who robbed the music store and got away with the loot.
So the loot is an instrument,
Yep,
correct?
we know that. Oh. And loot is in
And loot as in money. They robbed it. Okay?
Oh.
Yeah, I know. So all of these are kind of play on words. Okay? So we talked about this one in class, how you get 0.5, but we can't leave that as an answer. We had to rewrite it as 5 times 10. So when you had 0.5, you were moving it 3 places. Now you don't have to move it as far. It would have been 0.5 changes to this end. Okay? So again, I had some people do their work on the back of the sheet to show me. Either way, make sure you have your name on both papers. Pass it to the side. I want to go back to your notes. And you guys are going to pass it to that side. This row, you should pass it right here. You guys are going to pass it right over here. And you guys are going to pass it right here. The 2 sheets go to your notes, please. So, notes 10. Finish? All right. All right, listen up. We are going to be doing today the add and subtract. Okay? So, if we are looking at the add and subtract part, this seems to be the more difficult of the 2. The multiplication and division, a lot of people, oh yeah, that's pretty easy. The add and subtract, it seems to cause some major problems. So, to add and subtract in scientific notation, It says first, what we want to do, get both numbers to the same power of 10. When I talk about getting them to the same power of 10, what I really want is for you to go big. This was perfect a couple years ago when Big 98 started on the radio, because I could say go big, because that was their advertisement all the time, right? Okay, so go big. What I mean by go big is when you have an option between, I need you guys to stop. I can't have you whispering and talking while I'm talking, okay? So what I mean by go big is when you have an option to look at your powers of 10, you always want to choose to make sure you have the largest power, okay? Because you're going to be adding 2, and some of them are going to be of the same power, and then you might have like something with 10 to the 24th that you're adding times 10 to the 24th power, and something else that you're adding with times 10 to the 22nd power. You're going to go to the bigger number, okay? And we'll see that when we do this. And then it says, finally, write your answer in scientific notation. So we're going to add or subtract those coefficients. So what does that look like? We now want to do these 2 questions. And you're going to notice that the first 2, the powers of 10 are exactly the same. So please just line it up and go 3.6. Back here we're going to put times 10 to the 5th. So this is right in that page of your notes, 10. Go back to 10. We're not in 11. We didn't do the first part of 10. Then you're going to have 4.7. And since these are the same power, this is kind of nice, times 10 to the 5th. And you are simply adding 3.6 plus 4.7. This is going to stay as 10 to the 5th. You are not doing anything with those exponents. So right now, if you need to take out your calculator or just in your head, we're adding 3.6 plus 4.7. We should have 8.3 times 10 to the 5th. 6 plus 7 is 13, right? Carry in the 1. Okay, to give us 8.3. That's our answer. We're done. So some of them are pretty easy, but of course they can't stay easy that long. We now have this problem. Yes? The exponent stays the same. Okay? So if I notice this is 5th, as long as all of these are 5 in our answer, the exponent stays the same. Because I want you to think about what you're doing when you do this problem. So when I look at this problem, so the answer exponent is going to stay the same. And this is why this happens. Here's what you're doing. This really means 3, 6, right? 360,000, correct? And I'm adding to it 470,000. So should I really add the exponents together and make it 10 to the 10th?
No.
No, because I'm just adding these 2 numbers together right here, and I get 830. That's all I'm doing, right? But I write this number in scientific notation this way, okay? I'm looking at these 2, and I said to go big, right? This is my larger power. That means I need to change this. I need, and so what I'm going to do is I'm going to write down, does it matter if it's addition, which order I put them in?
No.
No. So we're going to put the 4.65 first. 4.65 times 10 to the 4th. I'm going to leave a little space between mine here and put this times and 10 to the 4th. Now, I need this number to be changed so that it's 10 to the 4th power. Okay? So, this was telling me to move it 3 places. What should I have for the number out in front here? Should it be 34 or should it be 0.345 as I'm looking at that? What are you thinking, Jaden? 0.345. Is that going to give us, are these 2 exactly the same answer? Okay? And if you're not sure, remember, you can move this over 3 places and get 1, 2, 3. This would be 3, 4, 5, 0. And if I move this one over 4 places, 1, 2, 3, 4, it'd give me the same thing, right? So I am going to line up my decimal points, 0, 3, 4, 5, times 10 to the 4th. These must be the same before you can add, okay? Must be the same exponent before you can add. And we are not adding the exponents. You are just simply, the only thing you really add is you're simply really adding this part. This is all we're really adding, okay? We're keeping this as 10 to the 4th. So we're going to keep this times 10 to the 4th. So when I add these two together, I get 5, 9, 9, 4.995, okay, times 10 to the 4th. Could I write it out in standard form? Yes, I would have moved this over 4 places, but they ask us to leave our answers in scientific. Question, Jack? Okay. Okay. So, subtraction. Does order matter for subtraction?
Yes.
Very, very much, okay? So, we need to be a little more careful here. So, we are going to look at these two problems, and again, we want to go big. So, we are going to put the 3.57. So, I'm going to go with 3.57 times 10 to the 15. I am subtracting. I need this to be times 10 to the 15. So, this was telling me to move it 14 places. If I need to move it 15, this is now going to be 0.465. Yes, everyone agree? Okay. So, it's really important that you understand converting them, just moving that decimal one place or the other, okay? So now we are going to subtract these. So when you do that subtraction, does the 10 to the 15 change? No, that stays exactly the same. Take 3.57, you need to add the 0 behind that, subtract 0.465. So again, as you are doing that subtraction, you might have borrowed from here and made it a 6, right? 10 minus 5 gives us 5. 0, 1, 3.105 times 10 to the 15. 0.95, my fault. No, 4.
No, it's 1. It's
1.
3.105.
Okay, so 3.57 minus 0.465, 3.105 times 10 to 15, okay? We don't want to put it to the smaller power. So let's try this next one. Oh, which power is bigger, -1 or -2?
-1.
-1. So I know that, and this is a tricky one, okay? So this is going to stay as 2.1. We could change subtraction. Let's do that to addition. This is the same as plus a negative. So right below the problem, put 2.1 times 10 to the -1. Okay? We need this to be 10 to the -1. So this was telling us to move it 2 places over. What is it going to be when it only has to be moved 1 place? 0.945. Does that make sense? This was saying to move it 2 places. We only want to move it 1 place, so it's going to be here. Okay? Now, here is where this gets a little ugly. And Mr. Roth and I were talking about this because he's like, how do you do it when it's a subtracting with this? If you've made it a positive, if you've made this addition, right? If you've made this into an addition problem, can I put this one first now? Can I put my negative first since I have it as an, I can. And that's what you want to do. So we want to think of this as negative 2.1 times 10 to the -1. And it's plus 0.945 times 10 to the -1. And I really want you to think about what these two numbers look like, right? This first one looks like this. 0.00, this first one, right here, looked like, I can if I was going to write this as a decimal, it looks like 0.0945. And then this one, in scientific notation, would have been, or in standard form, would have been negative 0.21, right? So sometimes writing these out in the other form, like the standard form, might help you. We're going to keep the 10 to the negative 1. If the signs are opposite, what do we do when we are working with adding integers and the signs are opposite? We're actually subtracting, right? My answer is going to be a negative because my negative was bigger. I'm going to add the 0, so it's really 2.100 minus 0.945. Does that make sense to everyone? And this is kind of weird stuff, and as we do your homework, you'll see it gets a little better, okay? So, we are getting what? 5. This is going to be a 9 minus 4 gives us 5, 2, 1. So we got 0.11255. But this isn't in scientific notation, right? It is negative out front. Okay? So, what's our final answer? Negative 2 point, I'm going to write it in the box. Give me the box. Negative 2.55 times 10. Now, this was saying to move it one place. If I put it over here, negative 2. Question. Oh, 1. So it was in scientific notation. 1.2255. Good thing you're catching me at the end of the day on a Monday. Okay? So, if you look at the rest of your notes, we have done the multiplication and the division. Good. You are going to go back to the worksheet, and now you are going to take a look at number 2. And you're going to finish the 10 worksheet, okay? You're going to finish that 10 worksheet in your workbook. I'd keep your notes in case you're struggling with this at all, but you don't probably need them too much. You're going to have this worksheet that we are going to look at right now, and then we'll come back, but your workbook should be on this page. Number 2, as you look at number 2, you need to show your work for what you are subtracting. So if you did not rank yours from 1 through 7, it's kind of hard to do number 2 right now. Number 2 says, what is the difference between the largest and the smallest, right? So when you look at your largest one in scientific notation, someone want to read to me what you had for the largest? Whitney. Give it in scientific notation. 2.03 times 10 to the 30. That's our largest, minus our smallest. What do we have for our smallest one? Yeah.
1.09 times 10 to the 22nd, which is Pluto.
Okay. So, we cannot subtract these as they are written, correct? We just said we have to go big, right? We want to go big on these two. So, which means what power should we keep them to? To the 30th, okay? Now, this worksheet, the front is a lot easier before, and we're going to do this worksheet before. You got to pick those up nicely and hand them all back. Just hand them, set them on his desk would be great, okay? So, if we are looking at this, 2.03, leave some space, times 10 to the 30th. Right now, not right now. This next one, we have to have it be 10 to the 30th power. It's 22nd. That means I'm moving it 22 places here, right? But we need it to be 30, which means I need to go, this would be 23, 24, 25, 26, 28, 29, 30. I need to have a decimal. It's a really small number, right? So put that, how many zeros did we say in front of it? 8. So, is it 8 zeros or is it 7 zeros? Count the front one. So 1, 2, 3, 4, 5, 6. Don't do that, please. So what am I up to? 1, 2, 3, 4, 5, 6, 7, 1, 0, 9. Now, if I am subtracting these, does this make any difference in my math? Is this very big?
Yeah, no, it's very small.
It's really, really small. So when I go to subtract these, and this is times 10 to the 30th, I mean, we could put down 1.969999, all of those, right? But this is really almost going to be 2.0, and then it's like 2, right? And then 99999, all of these.
Why would it be a 2 if there's just a 0 there?
Because you're going to put all these zeros.
Oh, yeah, then you have to.
Because you borrow. But what's going to happen after a while? If we're writing this in scientific notation, this is almost, isn't it almost 2.3 times 10 to the 30th? Is there much difference in their masses? I mean, it's such this huge, huge number. So if we are finding the difference, yes, I agree, this whole big ugly thing times 10 to the 30th, right? But the key thing to keep in mind is that when it's off that much, we don't look at all these other 9s behind here, right? We, after a while in scientific notation, because it's such a big number in this case, moving at 30 zeros, we kind of think of it as just, oh, that's about the same, 2.3, but 2.03, okay? So, I want you to look right now, so you're going to finish this worksheet with the addition ones. I agree these negative exponents, like in number 6, are somewhat tough. You want to do number 11, okay? And then we want to take a look at this worksheet. Look at the first page of this worksheet, please. Do you have to change any on the first page?
No.
None. Nope, of this sheet that I just handed out. There's a front and a back, okay? First page you should be able to do pretty easily. On the back is where it says change it to go big, right? Change it to go big. Which means I want this to be 10 to the 25th, and I want this one to be times 10 to the 25th, right? So this is kind of my hint would be I would do this before I would look at the questions in your workbook, okay? You do want to finish number 10. So today you are finishing 10, and then you have this worksheet is the C10, okay? It is attached to the daily planner also, if you are looking at that. So make sure you take a look. Wednesday of this week, we will be going into the computer lab. The counselors meet with us. They seem to always forget those of us teaching on this team, 7-2, that are in the 8th grade also. And since the rest of the 7th graders went with their math teachers, I think today, you guys are in there Wednesday. So we'll just move in those assignments back in. So tomorrow, we're going to be doing that raised to a power. Use your time in class.